Okay. So my last live stream that was like I think like 3 hours or something. If you were on it, it abruptly ended. I'm not sure why, but here is the follow up to that. Um, because we were, um, let me check something real quick here. Bear with me one sec. One sec here. Sorry, bear with me. I have to make sure everything's working, like the audio and stuff, before because if not, then it's gonna be a pain in the butt. But okay. It sounds better. I tested it. Looks good. Okay. So the last video abruptly ended. So I'm just gonna make this a part two since we're going back on the ZyBooks here. Um and we're going back and we're starting at three. So if you were with me the last one, you know that um, I was going through the practice test, but we got to a point using if statements um, where we haven't even gotten to because that is actually on number five here, right here. So it made me think like maybe it would be better to just go through the ZyBooks and then do the practice test after. But if you wanted to watch me go through the ZyBooks and like, figure things out as we go, like you saw me doing with one of the problems, took me like 30 minutes or something. And if that helps, I mean, it helped me because now I understand it. But if it helps you as well, then I can go and do that, and I'll do that in my live tomorrow. Um, if not, if you want me to go through each individual what do you call it lesson, then I can do that too. Either way, we're learning. I just know that people learn different ways, and if you want me to do like a separate video where it's like, okay, I'm only doing videos on just the practice test, then I can do that too. So whatever you guys request, then I'll try and make it work. But since nobody has said anything and nobody's going to watch my lives probably, then I am going to just start with where we left off on the ZyBooks going back. Uh, oh, and I just realized I'm not sharing my screen. Hold on. Then we're just going to start here with 3.1 and go through it because I was trying to show you, but I didn't realize you couldn't see it. But the if else statements, they were right here on number 5. And one of the questions, was that. And it was also like, um, the math module. So, we also did a couple of them with the math module as well, which we learned here. So in my brain, it made sense to go back and start here and just kind of go through each lesson there. But like I said, let me know if you want me to do videos on, going through the lesson, or if you want me to do videos on just the practice tests, or what it is. But either way, here we go. Okay. Uh, Here's a variation on children's riddle. For each step, keep track of the current number of people by typing the num people box. So 5. So for each step, keep track of the current number of people by typing in the num people box, which is this one. Oh, you are driving a bus. The bus starts with 5 people. 3 people get on. Are you wanting me to do math? Yeah, it's wanting me to do math. Okay. So 3 people get on. So now I have 8. So two people get off. So now I have 8, 7, 6. 4 people get off. Now I have 2. 5 people get on. So now I have 7. 4 people get on. So 7, 8, 9, 10, 11. So now I have 11. Yeah, they get on. Okay. The real riddle's ending question is actually, what is the bus driver's name? The subject usually says, how should I know? The riddle then says, I started with you are driving a bus. The box above serves the same purpose as a variable in a program introduced below. Variables in assignment, and like I said before, uh, I'm going through each lesson, and so basically it's like if you're not here, it's like if I'm just doing this on my own and I'm just kind of reading out loud to myself and then solving the problems. So if you want me to do it differently, like read it out loud or not read out loud or whatever, then just let variables and assignments. In a program, a variable is a named item such as x or num people that holds a value. An assignment statement assigns a variable with a value such as x equals 5. So this is the variable, this is the assignment statement, and this is the value of which x is holding. So it's like if you have a box and you have a letter or a note with the number 5 on it and you put it in the box. So now your box x is holding the value or the integer or you know the whatever it is inside that box. That's what that means. X is assigned with 5, and X keeps that value during subsequent statements until X is assigned again. So it's going to remain 5 until it's not, until you change it. An assignment statement's left side must be a variable. The right side can be an expression, so a statement may be x equals 5, y equals x, or z equals x plus 2. The 5x, so if you were watching earlier today, we kind of went through this, having a variable and then assigning the variable with a value, whether it's a string, integer, float. We used integers, floats, and strings. But that's what it's saying here. And it's saying that you can assign a value or you can assign a variable with whatever another variable is holding. So like right here, y is now going to hold whatever x was. And in this example, x is 5. So now x equals 5 and now y equals 5. That's what this would say. So let's go through this. In a program, a variable is placed to hold a value. Here, variables x, y, and z are depicted graphically as boxes. An assignment statement assigns the left side variable with the right side expression value x equals 5. Assign x with 5. Y equals x. So that means it's going to take 5 and place it into y. And now x plus 2 will now be placed in z, so z is now holding that. So now that x equals 3 was declared again, or I'm sorry, x was basically inputted and then equals 3. So you're changing the value of x to 3. It used to be 5, but because you expressed x equals 3 here, so now you're saying x now holds the value of 3. Which will change everything. It will change what goes next. So, x is now 3. So x plus y, so y still holds the value of 5. We didn't change what y is. So um, which was what, x, so 5, so y in algebra, an equation means the item on the left always equals the item on the right. So for x plus y equals 5 and x times y equals 6, one can determine x equals 2 and y equals 3. Oh, okay, this is a different example. Okay. Assignment statements look similar but have different meaning. The left side must be one variable. The equals isn't equals. I've been saying equals, but it's an equal signs. It's actually an assignment. Equals, but is an action that puts a value into the variable. So assignment statement only makes sense when executed. So basically, assign x with 3, with the value of 3. Assign the value 3 into the variable of x, whichever way makes sense to you. Same thing. Is not equals. I keep saying equals, but it's an assignment. Um, so I'll from now on, I'll try and use the word assign or assignment. In programming, equals is an assignment of a left-sided variable with a right-sided value. Indicate which assignment statements are valid. So x is assigned the value of 1. That's valid. X is assigned the value of y. So whatever y is, it will also be assigned to x. So that's valid. X equals, there I go again, x is assigned y plus 2. So the variable x now holds whatever number y was, or whatever integer, string, whatever it is, y has plus 2. So that is valid. X plus 1 is assigned 3. This is not, this is not valid. You can't express plus 1 uh, with the variable. So this would have to be moved to the right side of the assignment. So 3 plus 1 would be more accurate. X plus y equals x plus y. So just like I mentioned up before here, you cannot have, this to the left of the assignment. So that's invalid. Given variables x, y, and z, x equals 9. I keep saying equals. I'm sorry, I'll try and get out of that habit. So x is assigned the value of 9. Y is assigned the value of x plus 1. What is y? So that means x, we know that x is assigned y. So this would be 9 plus 1. So we'll say 10. And that is correct. X is assigned the value of 9. Y is assigned the value of x plus 1. What is x? Well, x is 9 because we know that the value that is being held or assigned to x is 9. X equals 9. Y equals, let me start over. X is assigned 9. Y is assigned x plus 1. So 9 plus 1. X is assigned 5. What is y? So y was not reassigned and x was not reassigned until after this assignment here, this declaration here. So it doesn't matter that x was assigned 5 after, because the y was already assigned 9 plus 1. So this is still going to be 10. But if this same assignment was after x is assigned 5, if that was down here, and then it asked me that same question, then I would say, 5 plus 1 is 6. I would say this is 6. Select the correct values for x, y, and z. After the following statements execute. Select the correct values for x, y, and z after the following statements execute. Okay, so is it just wanting me to click? So x is assigned 6, so x is 6. Y is assigned 9, so y is 9. Z is assigned 1, so Z is 1. Now, uh, it said to select the correct values for X, Y, and Z after the following statement executes. So if this whole thing executes, X will now be assigned 0. So I'm going to switch that to 0 now because it changed. The variable was reassigned with a 0, and that is correct. Oh, next. Okay, so X is assigned 6, so we're going to assign it to 6. Y is assigned 9, 9. Z is assigned 1. Now again, X is reassigned a 0, so we're going to switch this to a 0, and Y is now assigned to 1. So now we're going to switch this to a 1 and check it. Okay, again, X is assigned 6, Y is assigned 9, Z is assigned 1, and now X is reassigned with a 0, Y is reassigned with a value of 1, and Z is reassigned with a value of 3. And we're going to check that, and that's correct. X is assigned 6, Y is assigned 9, Z is assigned 1. Okay, so we reassigned X to 0, so we are going to say 0. Bear with me one sec here. X was so X was reassigned 0, Y was reassigned with a 1, Z was reassigned with a 3, and then X again was reassigned with a 9. So we're going to check that, and hooray! All right. Enter the output of the variable assignment. Note, each print includes a new line. So create a new line after your output by pressing enter or return on your keyboard. Type the correct program's output. So shouldn't this be 9, 6 then? Oh, I see, because print X, Y is on the same line. All right. Print includes a new line, so create a new line after your output. Oh, I see. It wants me to output, then press enter. Okay, I see. All right, type the program's output. So what it wants me to do is say print X, print the value of X, and then print the value of whatever Y is. So 7, 7, 5, enter, check. Print X, Y. So the value of X is 9, and the value of Y is 1. So now it's going to try and trick us. So we know that the value 6 was assigned to X and the value 3 was assigned to Y. But then X is reassigned to 8. So when it asks to print X, we're going to say 8. Y was not reassigned, it's still 3, so we're going to place 3 and hit enter. Don't be fooled. Same thing here. So this one here, so we know that the value of Y is 9, so we're going to put 9 here. X was assigned the value of Y as well, so we're going to say 9, 9, enter, check. Okay, so Y is assigned 6, X is assigned 6 plus 5, 6, 7, 8, 9, 10, 11. So 11 space 6, enter, check. Hooray! I just thought of something. I think this would be good too, like if somebody wanted to follow along. So if you like me doing that, let me know. Type the program's output. Okay, so y is assigned 5, x is assigned y plus 3. So 5, I mean 5 plus 3 5 is 8, but we can see here that 14 is the value that's assigned to y at the end. So y is being reassigned with 14. So x will be 8, 5, 6, 7, 8, because that's what it was first assigned, was a 5. And then we're going to say 14, not 5. Enter. Hold on. Assignment with variables on left and right. Ugh, excuse me. I forgot my water. Because in programming, equals means assignment, a variable may appear on both the left and right, as in x is assigned x plus 1. If x was originally 6, x is assigned with 6 plus 1, or 7. The statement overwrites the original 6 in x. Sorry. Increasing a variable's value by 1. As in, x is assigned x plus 1 is common and known as incrementing the variable. So I see that used a lot in like for loops and stuff, which again, I believe is C#. I don't know if it's called a for loop here. We'll find that out later. A variable may appear on the left side and the right side of the assignment statement. A variable may appear on the both sides of an assigned statement after x is assigned 1, then x is assigned x times 20, assigns x with 1 times 20 or 20, overriding x's previous one. So this is where we can see that x was assigned 1, and then x is assigned x times 20, which pretty much means x is assigned 1 times 20, which is 20. So, and then in this one, x is now reassigned to what x was last assigned, which was 20. So this would be 20 times 20 is 400. So now it's going to do the output. And because the last reassignment was 20 times 20 into x, x here will still equal 400, or still be holding technically, or assigned 400. Indicate the value of x after the statement executes. I'm so sorry, I keep yawning. Indicate the value of x after the statements execute. X is assigned 5. X is assigned 5 plus 7. So 7, 8, 9, 10, 11, 12. So that's going to be 12. X is assigned 2. Y is assigned 3. So X is assigned X 2 times Y 3. 3 times 2 is 6. So 3 times 2, this is 6. So now this reassignment of x on what value it holds is going to be 6. So when we say x again assigned x times y, now it's going to be 6 times 3. 6 times 3 is 18. So now y this x holds 18. So we're going to check that answer, and I'm correct. Y equals 30. I'm sorry, y is assigned the value of 30. So x is assigned the value of y plus 2. So now it will be holding the value, excuse me, of 32. So now that it holds 32, we're going to say 32 plus 1 is 33. So now the x is holding 32, 33. Complete this statement to increment y by 1. So to increment y by 1, I mean, it doesn't say what it originally holds, but I mean, wouldn't it be complete the statement? Wouldn't it be y plus 1? Yeah. Variables and assignments. Assign variable num primroses with 40. The output is 40. Oh, it's wanting me to. Okay. Assign variable num roses with 40. So so it wants us to do a variable of num primroses and assign it with 40. The output is 40, so the output should be 40, and it is. What happened? Oh, integers, num chairs, and num tables are read from input representing the number of chairs and tables a classroom has. Respectively, assign integer total into total furniture with the total number of furniture, chairs, and tables the classroom has. Example, if the input is 6, 7, then the output is 13. So it wants us to do total furniture, furniture. Remember, you got to type it out exactly, otherwise it'll fail. So total furniture, that's why I always make sure. So total furniture, if it, basically we're just adding it, so we're gonna say num chairs plus num tables. Okay, it already has the int. So we talked about this in the last video. We need every input is a string, so we need to convert it into integers in order to have this mathematical operation say, this number plus this number. Otherwise, you're just concatenating strings. So total furniture is assigned num chairs plus num tables. So it's going to take the two inputs, add it together, and output. Perfect. Integer num flowers is read from input representing the number of flowers a plant has. So here's the num flowers in the input. Then the plant grows 2 additional flowers. Write an assignment statement that increases num flowers by 2. If the input is 9, then the output is 11, 9, 10, because it increments it by 2. So what we'll do is we'll take, we'll say uh, num flowers. See, that would have been incorrect because I did it wrong. num flowers is assigned num flowers plus incrementing it by 2 and print flowers. Num flowers, check. And that is correct. Okay, last one. Integer num sardines is read from input representing the num of sardines a fish market has. So right here. The fish market then receives enough trouts such that they have the same number of sardines and trout. The next day, the fish market receives 3 additional sardines. First, write statements to update num sardines and num trout. Then assign integer total fish with the total number of sardines and trout. So num sardines is the amount representing the amount of sardines the fish market has. The fish market then receives enough trout such that they have the same number of sardines and trout. The next day, the fish market receives 3 additional. So it'd be like num sardines is assigned num sardines plus 3. So first, write statements to update num sardines and num trout. So what? So that means we will do. Come on. Num sardines equals so to update sardines. Okay, so it does want me to do num sardines plus 3, right? And then num trout does it want an input? Then assign integer total fish. So integer total fish with the total numbers of sardines and trout. So we reassign num sardines, so that should be an updated assignment of the variable of what the variable num sardines has now. Oops, sardines plus the number of trout, right? So let's say let's try it this way because it didn't say to hard code a number for num trout. Okay, so let's see what I did wrong. So integer input num trout EOF when reading a line. So input was 6, output your program produced no output. What? Nine sardines, 6 trout. Oh, okay. No, yeah, 9 sardines. So print num sardines equals num sardines plus 3 sardines. That should be, whatever the input is, right? So 6, 7, 8, 9, right? Because it went up, and then 6 trout. What if we did uh, the number of sardines, right? Because it said that it had the same amount um, to start with. So if we did sardines minus 3, because um, because it's going to look at this number here because that's what it was the last assigned, and I'm putting it after. Um, so it should. Let's see if that's correct. Yeah. Okay. So that's what it was looking for. Cool. And that was the last one. So yeah. So basically, the sardines was like, let's say, assigned 6, and then sardines was reassigned 6 plus 3. But the number of sardines and the number of trout began at 6. They were both equal. So now, because num sardines was reassigned, this num sardines is looking at this one here. So it'll be 6 minus, or I mean, it'll be 6, 7, 8, 9. So it'll be 9 minus 3, which is 6, and that's why what it was looking for. I need to. I just need to grab my water bottle. Okay. Okay. Identifiers. Rules for identifiers. A program gives names to various items, such as variables and also functions described later. For example, A is assigned 5, value of 5, uses the name x. To refer to the value 5, an identifier, also called a name, is a sequence of letters A through Z underscore and digits 0 through 9, and must start with a letter or an underscore. So it's teaching us how to create that variable, the naming conventions, and what's allowed and what's not allowed. Like, I can't name a variable one num cars or 23 num cars. It has to, like, let's say 23 num cars is what you want to name your variable, right? Because that's like your car, and that's what number you have on your car. You would instead do num cars or num car 23. Python is so with an underscore. So Python is case sensitive, meaning uppercase and lowercase letters differ. So if you did a cat variable with a capital C and a cat variable with lower c, it's going to be two different things. The following are valid names: ccat, cat, n1m1, short one, and underscore hello. The following are invalid: 42c, doesn't start with a letter or underscore. Hi there has a space. And uh, cat dollar sign has a symbol other than a letter, digit, or underscore. So it told you what it said, what the rules are here, and then it added that. What is going on? Um, Names that start and end with double underscore, for example, underscore init underscore, are allowed but should be avoided because Python has special usages for double underscore names explained elsewhere. A good variable name should describe the purpose of the variables, such as temperature. What the heck? Sorry, I keep getting notifications. Um, where did I leave off? Names that start with double. So basically, Don't start your variable with a number or try and avoid double underscores like it shows here. And it is case sensitive. So uppercase cat, lowercase cat, those are two different variables. So that's pretty much what this is saying. Which of the following are valid names? So num cars. So this is correct. It's using camel case. So we'll say valid. Num cars 1. So it follows that convention, starting with a letter and it ends with a number instead of a symbol. And it's using, I think it's called like snake case or snake something. I can't remember what it was called, but this is a valid variable. Num cars, so it uses underscore num underscore cars. You are allowed to start with an underscore and have an underscore to separate to the two words, so that is valid. Now this one actually looks like it has two. Now we did see that here it said names that start and end with a double underscore are allowed, but should be avoided. So it's saying, hey, you should avoid this, but it's allowed. So this should be valid. Num cars, this has a space in between and whoops, instead of an underscore. So this is not valid. I accidentally clicked valid. I'm sorry. Third place, this is not valid because it starts with a number. Now, if the number was like on this side or place and then 3RD underscore 3RD, that would be valid, but because it didn't, it's not valid. It did it say he could end with an underscore? Which is must start. I think it can end with an underscore, but let's find out. Yeah, okay, so it can. The name ends with an underscore, which is allowed, but it is not preferred. So basically the double underscore and the single underscore is not preferred at the end, but it's allowed. Yeah, if it's not preferred, why do they even make it allowed? I wonder if there's like some use cases or something. Third place. So because it uses a symbol instead of a number, it makes it invalid. Output. This is valid, but it would be best to use like camel case if you're doing it this way. But it is valid. The name is just letters of different. Okay, yeah. Return underscore copy. This is also valid. Style guidelines for identifiers. A good practice when naming variables is to use all lowercase letters and to place underscores between words. This lowercase and underscore convention for naming variables originates from PEP 8. PEP 8. Uh, descriptive naming style is what that means. Is that what that is? So Uh, the Python Style Guide PEP 8, Python Enhanced Proposal, outlines the basics of how to write Python code neatly and consistently. Code is read more often than written, so having a consistent variable naming scheme helps to ensure that programs can understand each other's code. Oh, programmers. So programmers should create meaningful names that describe an item's purpose. If a variable will store a person's age, then a name like age is better than a. So basically, it's saying, it's talking about having good naming convention and making it make sense. Not too long, not too short, but just right. I think that also takes practice, like it does to actually code. I think naming conventions also takes practice. A good practice when dealing with scientific or engineering names is to append the unit of measure. Example, instead of temperature, use temperature Celsius. Abbreviations should only be used if widely understood, like NYC is New York City, or oh, right here, UCLA is I think that's in Is that in Texas, UCLA? I don't know. Widely understandable, as in TV model or iOS app. While meaningful names are important, very long variable names also, let's talk about it here. Long variable names such as average age of a UCLA graduate student, holy crap, can make subsequent statements too long and thus hard to read. So, so programmers find a balance between meaningful names and short names. Below are some examples of names that perhaps are less and more meaningful. So the number of students attending the class. So NS, so less meaningful names is like NS, num, NU. A more meaningful name would be num underscore students. So that makes sense, number of students. The size of a television set measured by its diagonal length. So size TV, size. So this would actually be, I think I would maybe understand this, but it's still a little confusing. And then just size, like size of what? Size, height? Why did I accidentally click search? Hold on. I don't, if you know how to get rid of this, whenever I highlight, this pops up. If you know how to get rid of that, tell me. Or did I just see it right here? Oh yeah, hide menu. Hide menu for this site. Hide menu always. I hate that thing. Oh my gosh, I learned something new today. Sweet. Um, Instead, more meaningful, diagonal TV size inches. So that makes sense. The ratio of circles, circumference, circumference, diameter p pi. The number of jelly beans in a jar, num guessed jelly beans, user guessed jelly beans. See the okay, that makes sense. 1 second, please. Okay. All right. So what is this showing here? A list of reserved a list of reserved keywords in the language are shown below. Actually, I'm going to take a screenshot of this because this is very important to know. And if you're watching, you might want to take a screenshot too. Um, this would be a good reference of keywords that are not allowed to be used. So we can't name a variable false or for or from or all these other ones here. So, some of these I don't know. There's elif. Some of them I do know. Oh, source docs Python. Okay. So I mean, if you want to go look at it in more in depth, here's a URL here. Use a tool below to test valid and invalid names. Enter an identifier. So let's do. Um, Damn it. Let's do. I don't know. Num cars. Um, let's do. Let's do people seated, like sitting in a chair. Yeah, this is fun. Let's do. See, I don't really use the underscore before it, but I know it's legal and it shows it. What if we did lamps sold? Lamps sold Tuesday, right? Like on a specific day. Yeah. Okay. Let's move on from this. I always like to do those type of practice things at the end, like a few times at least, just for muscle memory, memory muscle. Um, and I think that's how you learn is just by like playing around with things like that. I also use, I don't know if you can, I don't think you can see it, but I have PyCharm open as well for like practicing. Objects. Before I continue with objects, I'm taking a drink. All right. The Python interpreter is a program that runs on a computer, just like an internet browser or a text editor. I had to like pause there, a comma there when it didn't read that way. Instead of displaying a web page or creating a document, the interpreter runs Python programs. An object represents a value and is automatically created by the interpreter when executing a line of code. For example, executing x is assigned 4 creates a new object to represent the value 4. So x is the object. So is x like an object variable or it's like something like that? A programmer does not explicitly create objects. Instead, the interpreter creates and manipulates objects. So the program is just reading it as an object instead of like a variable, and manipulates objects as needed to run the Python code. Objects are used to represent everything in a Python program, including integers, strings, functions, lists. The animation below shows some objects being created while executing uh, Python code statement in an interactive Python reader. The interpreter assigns an object to a location somewhere in memory. So let's start. Print 2 plus 2. The interpreter creates a new object. Okay, so this is the interpreter here. So the interpreter creates a new object with the value 4. The object is stored somewhere in memory. So it took this object here to the interpreter, and the interpreter interpreted it as 2 plus 2 is 4, and then put 4 in random access memory, or memory slot 96. So memory slot 96 now holds the value of 4 for that object. Once 4 is printed, the object is no longer needed and it's thrown away. So the memory prints out the object 4 once the object is no longer needed. Okay, so that 4 in the memory of 96 slot was the object. So now it prints out the object or the integer, and then it throws it away because it's no longer needed because it already provided it to us. New object created, X. Reference the object stored in address 98. So that's where the memory stored it. Objects are retrieved from memory when needed, sorry. So it's saying print X. So the memory sees it as, okay, so it is wanting the value in the object, in the X object, and then printing it out and giving it to you. Makes sense. That makes sense to me. Um, above the interpreter performs an addition of 2 plus 2, resulting in the creation of a new object with a value of 4. Resulting in the creation of a new object with a value of 4. Once 4 is printed, the object is no longer needed, so the object is automatically deleted from memory and thrown away. Deleting unused objects is an automatic process called garbage collection that frees memory space. So it's like temporary memory. It's what do you call it? Like temp caching or something? Name binding. Name binding is the process of associating names with interpreter objects. An object can have more than one name bound to it, and every name is always bound to exactly one object. Name binding occurs whenever an assignment statement is executed as demonstrated below. So name Bob's salary, and the object or the value for the assignment is 25,000, and the interpreter reads it, creates an object for 25,000, and holds it in the memory. Tom's salary. So it does the same thing with Tom. Creates an object for 30,000. Bob's salary. So it no longer needs that 25,000 because it's reassigned, and will now reassign it to that. Now it's going to use those objects because the names it already knew the variable what the assignment values were, which were the objects. Perfect. If any of this doesn't make sense, just let me know. Leave comments or just like I said before, leave comments to let me know what you want to see. Okay, properties of objects. Each Python object has three defining properties: value, type, and identity. Value. A value such as 20, ABCDEF, or 55. A type. The type of other objects such as integer or string. Identity. A unique identifier that describes the object, like X or unnum underscore cars or something. The value of an object is the data associated with the object. For example, evaluating the expression 2 plus 2 creates a new object whose value is 4. The value of an object is examined by printing that object. Let me read that again. The value of an object is the data associated with the object. For example, evaluating the expression 2 plus 2 creates a new object whose value is 4. The value of an object is examined by printing that object. Figure 3, the printing displays on an object's value. So create a new object with a value of 4 because of the 2 plus 2 referenced by X, the variable. Print the value of the object. So I'm going to print the object X and whatever value it holds. So that would be 4. Print 5, 5. Where are we here? The type of an object determines. I just realized I have to leave in like 5 minutes, 10 minutes. Yeah, 10 minutes. So we'll get as much done in the next 10 minutes as possible. Actually, we'll get the rest of this done, and then I'll stop until tomorrow. Where are we here? Properties of an object. Oh, we already read that. The type of an object determines the object's supported behavior. For example, integer can be added and multiplied, while strings can be appended with additional text or concatenated together. An object's type never changes once created. The built-in function type returns the type of an object. So if you saw my first I think it was my first video, I actually demonstrated an example of how to see what type um, what type of information or data is being how do I explain it? So I basically explained it by showing you that whenever you take an input in without saying, okay, this is an integer or float, it will automatically come through as a string. So I used the type function to kind of show you that. So if you didn't see that, you can check that out. But if yeah, that's what I did with type. So the type of an object also determines the mutability of an object. Mutability indicates whether the object's value is allowed to be changed. Um, changed. I don't know why I ended that with the question or whatever it was. Integers and strings are immutable, meaning integer and string values cannot be changed. Modifying the value with assignment statements results in new objects being created in the names bound to the new object using type. Okay. Create a new object with a value of 4 referenced by x. Print type x. So that's using the type function here. Print the type of the object. So it's going to print that this is an integer. And there's the example, same example I showed on the first video as well. Print type ABC. Create and print the title of the string object. So it's saying that the ABC is a string. The identity of an object is a unique numeric identifier, such as 1500 or that long number. Only one object at any time may have a particular identifier. The identity normally refers to the memory address where the object is stored. Python provides a built-in function, ID, that gives the value of an object's identity. So x, okay, so create a new object with the value of 4 referenced by x. So we can reference x and it'll tell us the value. Print the identity, memory address of the object. So it's going to show here that the identity, so the memory address of the object x. So x is currently in memory slot 175,260,008, whatever that long number is. Print ID ABC. And so now it's saying that ABC is stored in this memory slot here. Experimenting with objects. Run the following code and observe the results, type and ID. Create a new object called age that has a value of 19 and print the ID and type of the new object. So we'll run this. And it says that birthday year value is 1986. The type is an integer. And the ID, the memory slot ID, is this long ass number here. So if we add create a new create a new object called age. So age is assigned with the value of 19 and print ID and type. So we're gonna print we want to print, let's print the type first. We want to see the type that age is, and then print ID, and then see what the ID is. So we're going to run that. And so age is, I didn't do it like this, so it doesn't tell us. But I mean, you get the gist. You know, can I do that? Can I do that? No, I can't. That's what I thought. I think it has to be like within, you know, things like that. I think it has to be within that. I just kind of want to make it look make sense here. Do I have to like do it in quotes or something? Oh, maybe I can, but I have to do this. Maybe \n. Yeah, no, I'm not. You know, I'll learn about how to use new line later. Anyway, so yeah, so that's what it's showing. So let's finish this up because I gotta go. Which built-in function finds the type of an object? So that would be type function. Write an expression that gives the identity of a variable called my num. So the identity. So ID my underscore num. Perfect. All right. So tomorrow I am going to start on number 3.4 here. And it looks like we'll be learning about floating points. So kind of what we were doing earlier during the practice tests. Um, energy and mass conversion. Oh, okay. So we're going to be doing conversions. So that's pretty cool, actually. Overflow. So it seems like the kind of math we were doing. Um, oh, and look, it's actually going to teach us about the .2f as well. You know, the decimal places I was talking about earlier and the f string. So this will be fun. But that will be for tomorrow. So if you want to see something specific, if you would rather me, you know, have like videos I create that go through this in order, or if you want like videos that, you know, just do like the entire practice test 1 and 2, so that way, you know, whatever it is you want to learn, just let me know. I can definitely do that. But yeah, then we'll go from there. So later.